So today we're diving into the reliability analysis for equipment maintenance optimization. We all know how crucial it is to have reliable equipment in real-world engineering scenarios. Whether it's manufacturing, transportation, or energy industries, equipment failures can lead to costly downtime, unhappy customers, and a whole lot of headaches. However, reliability analysis allows us to tackle these challenges head on and keep our equipment running smoothly. Now let's talk about failure rate. Imagine you're an engineer responsible for keeping a machine up and running. The failure rate gives you insights into how often failures are likely to occur over time. Methods such as historical data analysis, statistical modeling, survival analysis are all used to estimate this failure rate. By studying this rate, we can identify patterns, predict future failures, and take the necessary steps to keep everything running smoothly.
The mean time between failures is simply the average of the time between two given failures in a system. A very common example that many of us have experienced is in a theme park when a ride is down for service. The time between one failure to another is the time between failures. Given many times where there was downtime in the ride, the average of them is the mean between failures. This can also be written as the integral from x to infinity of the reliability function t. This is a significant tool because it can be used to create an effective maintenance cycle for a given system to minimize downtime. As we can see in the picture, there is a graph of uptime being 1 and downtime being 0, where the average time between failures is the area under the curve that is created from the uptimes and downtimes. Reliability analysis starts with the reporting of failures in the system and noting the times of which failures happened. With the dataset gathered, we can start analysis. There are a few basic types of reliability analysis methods that we can use. The first is RCM, or Reliability Centered Maintenance. This is a method that prioritizes a positive outcome in the system over all factors, such as uptime. This will be expanded upon in the coming slides. Another common failure analysis method is FMEA, or Failure Mode and Effects Analysis. This, unlike RCM, looks at how things fail and how they can cascade in the system and make other things fail. Lastly, RCA, or Root Cause Analysis. This is a more general method that looks at all causes of failure in the system by looking at the big picture of why systems fail and how to fix it. Choosing which analysis method really depends on what your goal is in the current design.
Hey everyone, my name is Gabriel Cardona Toes, and I'm going to be talking about Reliability Centered Maintenance, or RCM, which is a maintenance strategy designed to optimize programs by establishing safe minimum levels of equipment upkeep by emphasizing matching individual assets with the maintenance techniques that are most likely to deliver more cost-effective outcomes. One example of this is when you're looking at a particular case, such as a light bulb, it would make more sense and would be more effective to just run it until failure. However, if we look at, let's say, a forklift, it would be more effective in the long run to use more preventative maintenance on it. And so we would implement RCM by using the following steps. And we would choose the equipment, identify its functions, its functional failures, its failure modes, and their effects. And then we will select maintenance tasks and then just evaluate and revise until you're satisfied. Now, this method gives us many benefits, like setting realistic expectations, providing more insight on risks, and managing those risks, and just overall cost reduction. Now, for the process of reliability-centered maintenance, we want to identify the critical equipment and failure types first. We do this by first defining or describing what a critical equipment really is. A critical equipment is one that could significantly impair the ability to safely meet business objectives, affect quality levels, and or just violate environmental standards of the organization. To identify the failure types for each equipment, you just have to simply diagram the entire process by which the equipment goes through in its use and catalog every possible failure that could happen in said process. After identifying everything you need, we need to prioritize maintenance resources to what equipment carries the most risk, so we ensure more efficiency and safety. And with this in mind, we develop certain maintenance plans for these priority equipment to ensure like the minimization and mitigation of the risk it carries.
The lack of accurate companies like to keep a technician on hand for any of their products having failure, but a lot of the time that ends up having the cost on production time and preventing deadlines from being met. If a company is big enough, they'll have a small team of technicians for the entire place that may consist of thousands of machines. The problem is when there are only so many people that can go fix things at once. That's where equipment maintenance optimization comes into play. This would count as teaching and informing all of the workforce how to maintain their equipment and simple fixes. By keeping the maintenance more proactive than reactive, the machines are less likely to break down, and if they do, there will be many people on hand that will be able to repair the problem. The lack of accurate and thorough data on equipment failures and maintenance operations is one of the key problems. This may prevent precise analysis and forecasting. Establishing system and processes for data collecting is crucial. This can be done by combining information from numerous sources, including work order systems, sensor data, and maintenance logs. Through the use of proper data analysis tools and the implementation of data collecting techniques, along with that, educating and training every person who uses the devices is an excellent source to have on hand so that they don't need to always have a professional on hand, which would save money and resources.
Taking into account all the topics covered today, one could see how critical this process is to operations. The last thing we want to see is a total shutdown of business due to one break in the logistics chain. Proper statistical analysis of equipment allows us to proactively fix and upgrade our processes to ensure stability.